Hi guys, welcome to lesson 9.6, the quadratic formula and the discriminant.
It's me! I'm here!
Yep. So our objective for today is that I can solve the quadratic functions using the quadratic formula. Yay! Our essential understanding, unlike previous lessons for this one, you can find the solution or solutions of any quadratic equation using the quadratic formula. The quadratic formula will solve every single quadratic formula or equation, and it will give you all of the solutions if there are some. So, what is this wonderful quadratic formula that I have mentioned multiple times? Mrs. Zirzo is writing down that you should memorize this, and she is absolutely right, because I can tell you, I believe it's question number 11 on your Chapter 9 test is going to be exactly this. What is the quadratic formula? I think it's question 11. So, quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So, you need to memorize that formula. And that formula, again, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, notice I'm saying the opposite of b, not negative b. Because if b is a negative number in your equation, you need to take the opposite of it and make it positive. So it is the opposite of b. All right. So, letter A in problem number 1, using the quadratic formula, Mrs. Zirzo has already started writing in some information. So above the equation, she identified what her A, B, and C values were from the equation. So A is 1, B is negative 3, and C is negative 10. Negative 10.
And it's already set equal to 0.
Yep, it's already set equal to 0, so we don't need to do anything in terms of putting it in standard form. So she wrote the quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So she needs to substitute the pieces of information in. So the opposite of b is positive 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times 1 times negative 10. Divided by 2 times 1. So, negative 4 times 1 times negative 10 is positive 40. So you have negative 3 plus or minus 9 plus 40 over 2. 9 plus 40 is 49. Plus or minus 3 plus or minus the square root of 49, which is over 2. Square root of 49 is 7. So we're going to split our equation into our formula into two equations at this point. 3 plus or minus 7 over 2. So 3 plus 7 is 3 plus 7 over 2. 3 plus 7 is 10. Divided by 2 is 5. Okay, our second one, x equals 3 minus 7 over 2. So x equals negative 2. It's negative 4 over 2. Negative 2. Okay?
You don't leave me any room to do these, Mr. Boland.
Sorry. All right, our next problem, x squared minus 4x minus 21. She identified our A, B, and C already. A is 1, B is negative 4, C is negative 21.
Why is C negative 21?
Oh, that's right, because it wasn't in standard form to begin with, so we needed to subtract 21 from both sides so that we are equal to 0. Anytime we're solving these, either by factoring or by the quadratic formula, or completing the square, we want them in standard form at some point. All right, so there's our equation. Now we are going to use the quadratic formula, the opposite of b. So the opposite of negative 4 is positive 4. plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times 1 times negative 21. Okay, so x is equal to
all over 2
times 1.
Okay. Don't know that my writing's much better.
So x equals 4 plus or minus 16 plus 84. 16 plus 84. All over 2. Push it up. So we've got 4 plus or minus the square root of 100 over 2. X equals 4 plus or minus 10 over 2. So x equals 4 plus 10 divided by 2. And x equals 4 minus 10 divided by 2. 4 plus 10 is 14, divided by 2 is 7. 4 minus 10 is negative 6, divided by 2 is negative 3. Okay. Now, letter C, we have 2x squared plus 2x minus 12 is equal to 0. A is 2, B is 2, and C is negative 12. Ms. Irzo wrote those in for us already. So we substitute. Opposite of B is negative 2 plus or minus the square root of b squared, which is 2 squared is 4, minus 4 times 2 times negative 12. All over 2a. 2 times 2 is 4. Okay, so x is the opposite, or negative 2 plus or minus the square root of 4 plus 96 over 4. So x equals negative 2 plus or minus the square root of 100 over 4. X equals negative 2 plus or minus 10 over 4. Over 4. So negative 2 plus 10 is 8, divided by 4 is 2. Negative 2 minus 10 is negative 12, divided by 4 is 3. Negative 3.
Mr. Bolin, is there an easier, faster, quicker way to do this?
Yes, there is. We can use our calculator to our advantage on these problems.
Really?
Yeah.
Oh.
So we can type into our calculator if we've got the opposite of, so we can take care of our radical parts. So we have 2 squared minus 4 times 2 times negative 21. And we typed that all in our square root, hit enter. Wait. B squared, 2 squared, minus 4 times A times C. Oh, C was 12 on this one. Had the last one in my head. There you go, 10, plus or minus 10. So we can shortcut some of our work there. But we do really want you to be starting off by writing everything in the quadratic formula already so that you can make sure you're putting things in the correct order. So, okay, we need to be doing the steps. Did you have another shortcut in mind? Okay. So, letter D, we've got x squared minus 2x minus 24. So let's plug those into the quadratic formula. X equals the opposite of b, so the opposite of negative 2 is positive 2, plus or minus the square root of negative 2 squared, which is 4, minus 4 times 1 times negative 24. all over 2 times 1. So we get 2 plus or minus the square root of 100 over 2. And we know the square root of 100 is 10. So we've got x equals positive 6 or negative 4. If you want to see all of the steps worked out, ask us in class, and we will walk through every single step on these. Okay. So letter E we need to convert into standard form to begin with. So we need to subtract 4 from both sides of our equation. And we get 5y squared minus 1y equals negative 4. And we are just going to kind of shortcut down to our solutions. X is equal to positive 1 or negative 4/5. Okay. Letter F, again, we have to get it into standard form, so we are going to subtract 40x from both sides. So you get 4x squared minus 40x plus 100 equals 0. Put that into the quadratic formula. When you work it through, you get x is equal to 5. Because this is a fun one. When you actually type in the b squared minus 4ac, you get square root of 0. So the square root of 0 is 0. So you're not adding or subtracting anything to that initial amount. All right, so problem number 2, finding approximate solutions. Right now, everything we've had has been a very nice decimal, right? You know, the messiest one we had was 4/5, negative 4/5. So now, if you look at this equation, when we deal with the real world, these are not going to be pretty numbers. So just accept that right away. So we have a batter hitting a baseball. The equation y equals negative 0.005x squared plus 0.7x plus 3.5 models its flight path, where x is the horizontal distance in feet that the ball travels, and y is the height in feet of the ball. How far from the batter will it land? So we start off with our quadratic formula. X equals the opposite of b, which is negative 0.7, plus or minus the square root of b squared. 0.7 squared is 0.49, minus 4 times negative 0.005 times 3.5. Okay, so we have 0.7 squared minus 4 times negative 0.005 times 3.5. Okay. And we get x equals negative 0.7 plus or minus the square root of 0.49 minus or plus 0.07 all over negative 0.01.
Yuck!
Yep, it's gonna be messy, guys. Sorry, but this is the real world. Real world's not nice and pretty. So when we simplify that, 0.49 plus 0.07 is 0.56. So we have negative 0.07 plus or minus the square root of 0.56 over negative 0.01. And this is where we can use our calculator to do this work for us. So we have negative 0.7 plus the square root of 0.56. And when we type that into the calculator, you need to be very intentional with how you do it. And I'm going to show you the example. What you need to do is you need to make sure that you put the numerator of the fraction, the negative 0.7 plus the square root of 56, inside parentheses, so that by order of operations, it's going to do that addition before you divide by the negative 0.01. Okay, and then when you do that, you'll get one of your answers, which was negative 4.83 feet. And then you would do the same equation, but you would subtract the square root instead, and you would get the 144.8 feet. Okay? All right, so either he foul tips it and it just goes 4.83 feet behind him, or it goes 144.8 feet out into the outfield. So there are two possible solutions of where that ball is going to end up.
Most likely?
Most likely, it's going to be that positive value. Okay. All right. Second problem, we've got how far from the batter will the ball be when its height is 23 feet. So we know that 23 is our y value. So 23 equals negative 0.005 x squared plus 0.7x plus 3.5. So our first step on this problem would be to subtract the 23 feet so that it is in standard form. So we get 0 is equal to negative 0.005 x squared plus 0.7x minus 19.5. So again, we're going to use quadratic formula. X equals the opposite of b, so negative 0.7 plus or minus the square root of 0.7 squared. Well, we could just write 0.49 because we know that from the previous part. Minus 4 times negative 0.005 times negative 19.5. Okay. And divided by 0.01. And when we multiply that, we get the square root of 0.1. Sorry. Mrs. Erzo's just jumping down to the answer. X is 38.38 feet, or X is going to be equal to 101.62 feet. Now, if we're thinking about the arc of the baseball, this would make sense, because as you hit it, it's going to climb and hit 23 feet as it's going up, and then it's also going to be at 23 feet on its way down off the ground. So as it is going up and down, you're going to hit 23 feet at two different points, okay? And they would both be out in front of the batter. All right, last problem on this section, we have Greg, and this is Greg. He is tossing a baseball across the playground. The arc of the ball can be modeled by the equation y equals negative 0.005x squared plus 0.75x plus 4, again, where the x is the horizontal distance in meters and y is the height of the ball.
Couldn't you find any prettier equations?
No, because the trouble
Because life is not pretty.
Yeah,
I get it.
Life isn't pretty. We'll just leave the jokes lie there. How far from the ball is the? How far from Greg will the ball land? So we have x equals the opposite of 0.75, negative 0.75, plus or minus the square root of 0.75 squared minus 4 times negative 0.005 times 4 divided by negative 0.01. Because we've used that a couple times now, we can shortcut that step. So this is calculator heavy work.
Thank God for calculators.
Yep, pretty much. X equals negative 0.75 plus or minus the square root of 0.6425 divided by negative 0.01. And when we type that into our calculators and we do each of the steps, we get x equals 5.16 feet and 155.16 feet. And that was actually negative 5.16 feet. So either when Greg was throwing the ball, it slipped out of his hand and fell behind him.
Typical Cub.
Or, yeah, he's a Hall of Famer.
Yeah, whatever.
Greg Maddux, Hall of Fame.
Okay, whatever.
He actually is a Hall of Famer.
All right.
My favorite baseball player.
Yeah, whatever.
Anyways, or most likely it went 155.16 feet in front of him and then landed. All right, so moving on to our next section, problem number 3, which is choosing an appropriate method to use when solving a quadratic. Now we have all of our forms listed here. We've got quadratic formula, graphing, square roots, factoring, and completing the square. Ooh. So you have all of these forms that we can use. Which one is the best method to use in a particular situation? I mean, we told you today the quadratic formula will work for all of them. But as you've seen, the quadratic formula has a lot of work that you have to do along with it. And sometimes there are other methods that are going to be much easier to use and much faster to use. All right, so x squared minus 8x plus 12. Well, factors of 12 that add up to negative 8. Ooh, that's easy. I know how to do that. That's what we did at the beginning. We know how to do that. Factoring is the easiest one. So most likely, if your a value is 1, you're going to want to be factoring. Unless it is, it has stuff that doesn't factor neatly. 169x squared plus or equals 36, that's going to be using square roots because you have 2 perfect squares on both sides and you don't have a b term there. So if there's no b term, you want to use square roots. Letter C, 5x squared plus 13x minus 1. Yeah, a term is a big or a 5. I'm going to use quadratic formula on something like that. If I can't look at it quickly and identify what my factors are going to be, it's going to be quadratic formula. All right. So letter D, x squared minus 32. No b term there. They're not perfect squares, but square roots is going to be the easiest method because you're going to add 32 to both sides, and then you're just going to take the square root of 32, and it's going to be some irrational number. So square roots is the best method on that. If you don't have a b term, you're going to want to use square roots. Letter E, if we wanted to try to use box method on that, you're looking for factors of 33 that add up to negative 17. I don't know of any, so we're going to use quadratic formula. That's going to be the best method on that. Last one, x squared plus 7x plus 10. Oh, well, that's, a is 1. Factors of 10 that add up to 7, 5 and 2. That's easy. You're going to do factoring on that one. Okay, so you can see how quickly factoring can work. You could use quadratic formula like we did in problem A and problem 1, but you don't have to. Factoring is quicker. All right, now problem 4, a very important part, using the discriminant. The discriminant is this piece that's underneath your square root symbol. B squared minus 4ac. Okay. And our key concept there is telling us that if b squared minus 4ac is greater than 0, this means we're going to have 2 solutions. If b squared minus 4ac is equal to 0, we're going to have 1 solution. And if it's less than 0, we're going to have no solutions. Okay, now let's think about this. This makes sense. If we are adding, because we have plus or minus the square root of whatever the discriminant is. If that's a positive number, we're going to be adding and subtracting whatever that root is. If that is 0, the square root of 0 is 0. So we're not adding or subtracting anything. We're just having 1 solution. And can we take the square root of a negative number? No, we cannot in this class. So,
I was doing some advanced writing.
Yep. So we've got problem A, 6x squared minus 5x equals 7. First, we need to write it in our standard form, which is 6x squared minus 5x minus 7 equals 0. So when you plug that in, negative 5 squared minus 4 times 6 times negative 7. And we get 25 plus 168. That's going to be a positive number, so we have 2 solutions. And at this point, we're not asking you what they are. We just want to know how many there are. Letter B, 2x squared plus 7x minus 15, already in standard form. So b squared minus 4ac, we've got 7 squared is 49, minus 4 times 2 times negative 15. And when you do all that math, you get 169. (120) minus negative 120 minus 1 minus negative 120 minus negative, which is plus, and you get 169. So it's positive. There are 2 solutions. Okay. Letter C, x squared minus 4x plus 4. This is already in standard form because it's equal to 0. B squared, so negative 4 squared is 16 minus 4 times 1 times 4. Well, 16 minus 16 is 0, so it is 1 solution. Fourth one, letter D, 9x squared minus 3x minus 8 equals negative 10. We need to start by adding our 10 to both sides to put it into standard form. So we have 9x squared minus 3x plus 2. So plugging that in, we've got negative 3 squared is 9 minus 4 times 9 times 2. So we have 9 minus 72, which is negative 63. No solution. All right. So that is the end of our lesson for today.
We're taking 2 days on this,
We
right?
are taking 2 days on this. So
It's a lot of work.
It is a lot of work. So when you guys are writing down your reflection, make sure you associate your level of understanding. Write down any questions or confusions you have if you want us to go back and rework some of the problems or maybe show all of the steps. We are going to take multiple days on this, but this is a formula you must memorize. You must memorize it. Okay? So take your time, make sure you practice a lot, and we will see you in class.